and we have heating under distillation. And this is something you are almost certainly going to be asked about in your papers at the end of the next year, about how we selectively produce these different molecules. So in the reflux setup, we take our round bottom flask, we then attach a condenser. I apologise for my terrible drawings. So our reaction mixture is in here. We've got our alcohol, we've got our acidified potassium bichromate, and we're going to heat it gently with a heat source underneath. You'll use a water bath when we do it in the practical. So our alcohol is going to get oxidised to form the aldehyde. The aldehyde is very volatile, and so it's going to boil off. But the condenser is going to condense it, and it's going to return back down into the reaction flask down the bottom, where it's going to then meet another equivalent of the oxidising agent, and it's going to get oxidised further to the ethanoic acid. So this means that with this reflux setup, all of the reagents are kept inside here. None of them can escape. So anything's going to get condensed because it's going to be below the 30 degrees with the cold water running into the condenser, and so none of this ethanol can escape. For the distillation setup, we use a classic distillation setup that you would have seen all the way back from year 7 even. And we're really using the same equipment, we just need one of the still heads just to change the direction. So rather than attaching the condenser directly above, we attach a still head. So the still head is this piece of equipment that's got this shape. You normally, you either bung it up at the top, or very commonly you get a bung with room for a thermometer to come into, which helps you track the temperature of the vapours coming off. So this is a thermometer. And you place it just at where the glass changes direction in the still head, and so you can record the temperature of the vapours. Then you attach your condenser, your Liebig condenser, and you have that drain into a test tube, which we're commonly going to put in a bucket of ice water. Now, under this setup, the aldehyde is going to be produced by the oxidation of the alcohol, but it's, as we said before, it's very highly volatile. It's going to evaporate quite quickly. Some of it will not escape the reaction mixture and will get oxidized to the carboxylic acid. But a substantial amount will evaporate and it will condense, but this time it's set up in such a way that any of the ethanol that condenses doesn't return back into the flask. It just goes into the test tube down here. So it's going to drip down in here, and we're going to collect the ethanol in here. Now the ethanol is very volatile, so if we left it at room temperature, a lot of it would just evaporate slowly. So we put it in the ice water to stop us from losing too much of our product. So this is how we're going to select which product we're going to form, is by changing the setup. We don't really need to change much else. Now the ketone, if you want to produce the ketone from the secondary alcohol, you're going to use the reflux setup. It ensures that you don't lose any of either the starting material or the final product, because propanol has quite a low boiling point as well. So you can use the reflux setup, an excess of the oxidizing agent, and it helps make sure the reaction goes to completion. So that's all you need to know about oxidation of alcohols. I'll send you some questions so you can go and practice those things.